categorize numbers. We're going to talk about what group numbers fit into, what labels we can put on them. So it says numbers can be placed into different categories, including irrational, rational, integers, whole numbers, and natural numbers. So the very first thing that we check is right here at the top. Every single number can be categorized as a rational, R-A-T-I-O-N-A-L, a rational number, or we may call it an irrational number. That is the very first number, or very first thing you check. Rational and irrational. So right away, it's like, well, how do I know if it's rational or irrational? I give you hints. Is it a fraction or a repeating decimal or a terminating decimal? Then it's rational. If you have a number that's got a crazy decimal that never ends and there's no pattern to it, it's irrational. Can anybody think of a number that goes on and on and on forever? There's no pattern to it whatsoever, and we use it in math? Zayden? One doesn't go on and on forever. Crazy decimal. Petro? No, everybody stop and listen to everything I'm saying. It is a crazy decimal. It never ends. There's no pattern to it whatsoever. Rejoice. I can wait for as long as you want to screw around. That's less time you work on your homework. Leanna, what are you thinking? Nope, it's a number in math class that we use. It goes on and on and on and never ends. There's no pattern to it. Jack?
1.666.
It is pi. 3.14159, blah, 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 blah. If you type it in your calculator, it's a really long decimal. It never ends. So if you call a number irrational, that's the only category it's going to get. You don't have to label it as anything else. But if you say that a number is rational over here on the left side, you have to check if it can go to the next category. Oops. And the next category is integers. Integers, a positive or negative whole number. So there's no longer decimals, a positive or negative whole number. And then we can take those integers and we can make them an even smaller group called whole numbers. And those are only the positives. So at this point, we no longer even have to worry about negative numbers. And then the very bottom one is called natural numbers. Natural numbers are all the whole numbers excluding 0. All the whole numbers excluding 0. Take your hood off. Okay, then set your pencil down. I always like to give you an example of this talking about Brandon Valley School District. Okay? So we can think of rational numbers like all the kids in the Brandon Valley School District. There's like 4,500 of you. And we can narrow that group down to a smaller group like integers by saying these kids go to the middle school. It doesn't include everyone, but it includes a large chunk. And then of the kids that go to the middle school, we can say, well, these ones are 8th graders. And then of those 8th graders, we can say these ones have Miss Hoff as a math teacher. So you guys right here, do you belong to the Brandon Valley School District? Yes. Do you go to the middle school?
Yeah.
Are you an 8th grader? Do you have Miss Hoff for math? Yes. Okay. What if I went next door to Mrs. Hoosier's room and I grabbed one of her kids? Do they go to the Brandon Valley School District?
Yeah.
Do they go to the middle school?
Yeah.
Are they an 8th grader? Do they have Miss Hoff for math?
No.
No. So they would not get to be called natural numbers, but they would be rational, an integer, and a whole number. Okay. What if I went over to Mrs. Ring's class, math teacher across the hall? Do her kids go to Brandon Valley School District?
Yes.
Do they go to the middle school?
Yes.
Are they 8th graders?
No.
No. So sometimes numbers are only categorized so far. That's what we're going to practice today. So I did this intentionally. This note sheet doesn't have anything on the back. I want it to be able to just sit on your desk so you can reference it. I have another piece of paper here that are example problems from your homework that we're going to do together. But this way you didn't have to flip back and forth and back and forth. So leave your circle chart there so we can talk about it. And then we're going to do these problems together. Okay, this is the problem you should have up. These are exact problems off your homework. This is exactly what your homework looks like. So pay attention, and your homework is going to be significantly easier. So the first part says classify each number as rational or irrational. On your chart, we reminded ourselves rational numbers are fractions, repeating decimals, or terminating decimals. Irrational numbers are crazy. They never end and there's no pattern. So don't shout these answers. I'm going to call on people because I want everybody to have a chance to think. If it's a fraction, a terminating, or a repeating decimal, it is rational. Okay? So let's look at our numbers. The very first one, negative 95.51 with a line above it. I need to know if it's rational or irrational. Bryce. Why? Okay, that bar notation means it's repeating. Okay, but you are still right. Rational, it is. Because of that line above there means it's repeating. Nicely done. Then we go to the next one. 2/3. Don't shout. Everybody look at your chart. Is it going to fall under rational or irrational? Marilyn, what do you think? Why? Bingo, 100%. Rational. It's a fraction. It's a fraction. The next one is 3 pi. Rational or irrational? Sarah? Perfect, 100%. As soon as you see that pi symbol, this pi symbol right here, number one indicator, as soon as you see it, irrational. Okay, square root of 25, everybody. Oh, I didn't have you grab a calculator today, did I?
No.
Pause for a minute, get your calculator out. If you need one, go get one. Good work. Do you remember from yesterday how to type in that square root of 25? Okay, don't shout. Everybody type in the square root of 25. Remember, you have to use that second key to get that square root on there. When you type in the square root of 25, what does your calculator say? 5, okay? So is 5 rational or irrational? Petro?
Irrational.
Why?
Wait, I'm gonna say it. Yeah.
Why? Very good. Terminating means it ends. There's not any numbers after 5. It's just a 5. He is correct. He fixed his answer to be rational. When it's a whole number, it's rational. Okay, everybody type in the square root of 17 on your calculator. Type in the square root of 17 on your calculator. Tone, are you thinking rational or irrational? Say it again. Irrational. Why? Yeah, it's long. Is there any pattern to it? I don't see any type of pattern. You are 100% correct. Irrational. That filled your entire calculator screen. There's not a 0.66666 or any type of repeating whatsoever. Okay? Awesome job so far. Okay, this next problem, people panic. Don't panic. Okay? Ms. Hoff's going to help you. It wants to know, for each number, can it be written as a fraction, and then tell me why. Ms. Hoff tells you, answer the reason first. Answer the reason first. If it's a terminating or a repeating decimal, we'll say, yes, it's a fraction. If it's not terminating or repeating, then we'll say no. Okay? So everybody right now, don't say it out loud. 0.63. Tell me, is it terminating? Is it repeating? Or is it neither? Don't say it out loud. Terminating meaning it ends. Repeating means the same number or numbers happen over and over. Or if it neither terminates or repeats. Tegan, what do you think? It doesn't terminate or repeat? Thoughts? Petro? Why? It stops. This is a terminating decimal. 0.63. Done. Over. It is 2 numbers long. Because I said it's terminating, can you write it as a fraction? Yes. Because we said it's terminating, yes, we can write it as a fraction. So then we look at the next one. 0.8 with a bar above it. Everybody answer on your own. Terminating, repeating, or neither. Courtney, what do you think? Terminating, repeating, or neither one? Why do you say repeating? 100%. I love that. It is repeating because it has that bar. So because she says it's repeating, yes or no, it can be a fraction. Yes. Yes. 0.555 ... What do you think that ... means? It keeps going on. Terminating, repeating, or neither one? Repeating. If it's repeating, can you write it as a decimal? Or as a fraction, sorry. Yes. The top 2 answers are always yes. The bottom one, 0.581372 ... Petro? The bottom one? Neither terminating nor repeating. There's no pattern here. Means it's not repeating, and ... means it continues on. So if it's neither terminating nor repeating, can it be written as a fraction? No. No. Good work so far, you guys. Good work so far. Okay? All right, I'm going to make you do the next ones on your own before I answer any questions. Flip it over. Classify each number below as an integer or not. Remember, integers are positive or negative whole numbers. What's a whole number? Like, how do you, when you look at a number, how do you know if it's a whole number? Jack?
If it doesn't have any sign.
No. How do you know a number is a whole number, Courtney?
Oh, if it's just one number. If it's like a number in front of a fraction or something like that.
What's not a whole number? Pedro? So look at the first one. Negative 89.88. Is that an integer? Yes or no? Why not? You got to have a reason why. You can't just say an answer. What's a whole number? How do you know if a number, say it again? 32. What's another whole number? Give me another example of a whole number. 15. 1. Tell me what all of those numbers have in common. They don't have a decimal. So integers are positive or negative whole numbers. Whole numbers do not have a decimal. So your integer could be positive or negative, but it can't have a decimal. So I'm going to ask you again. Negative 89.88. Integer, yes or no? No. Negative 13 over 12. On your calculator, type in 13 divided by 12. Integer, yes or no? Okay, do the last three on your own, and then I'm going to check in with you. Do the last three on your own, and then I'm going to check in with you. All right, Miss Youngkong. Negative 782.97. Integer, yes or no? She says no. Do you agree with her or disagree?
I agree.
Good work. I agree with you. Negative 32, Sam. You say yes? Do you guys agree or disagree with him? Okay. And Caitlin, negative 8/4. You said yes, but that's a fraction. When you take 8 divided by 4, what'd you get? 2. Very good. Actually divided out. That 100% is yes. Very good for not getting fooled by that. Okay. All right. Last one. This kind of looks like maybe your diagram sitting right next to you. Yes? Okay. So see these four number or words right here? We have to label the different pieces. Okay, everybody take a minute. It's going to look just like your diagram that's at your paper. Okay? What is the easiest one to label? Where's that one going to go, Jack? I 100% agree. He pointed right here. You guys don't have, it's not colored on your paper, but he said right here, rational, and I agree with that. Whoopsies. Rational numbers. I don't know why that thing keeps popping up. It needs to be shut off. Okay, what's another easy one to label? Courtney? And where's irrational going to go? Excellent. Irrational is going to go over here on the right side. Okay. What's the next one you want to label? Integers, where's that one go? which one are you putting it on? Marilyn says integers goes here. Do you guys agree with that?
Yeah.
Integers is a bigger circle than whole numbers. Very good. Whoopsies. Integers and then whole numbers. Good job. Okay, so what we need to do now is we need to put these numbers that they gave us into the right categories. Okay? So I'm going to move over here. The number is negative square root of 81. In your calculator, what is the square root of 81? 9? So really this is a negative 9 number. Is negative 9 rational or irrational? Why? It doesn't have a decimal. Very good. So it's here. Because we say rational, we have to check. Is it an integer? What is an integer? A positive or negative whole number. Is negative 9 a positive or negative whole number? Okay. Is negative 9 a whole number? Tone's the only one that shook his head no. Why do you say no? You're right. Why is it not a whole number? Because it's negative. So the smallest category that this can go into would be integers. God dang it, I don't know why that thing keeps popping up. Negative square root of 81. So we would draw it in that circle. .69 with a bar above it. Rational or irrational? It repeats, so it's rational. 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 Okay, after rational, we check. Is it an integer?
No.
What's an integer? A positive or negative whole number. Is this a positive or negative whole number?
Yes. No.
That's a decimal. So the only category that can go into is out in the rational category. $37. Rational? Integer?
Yes.
Whole number.
Yes.
All the way down on that little circle on the inside. Positive, and there's no decimal to it. 45. Rational. All the way down to whole number again. Good job. Okay, -4, and then there's a square root 13. Just type the square root of 13 in your calculator once. What do you have? A big, long, nasty decimal. What are you going to say? Irrational. Irrational. Come on. The nice thing about this, I don't know what is wrong with that thing today. If you type that square root in there, I don't even care what the rest of it. If it's a long, crazy one, you're going to put it over there. Okay? These are the 4 problems you're going to see today. When you're working, you have to try the problem first before you can raise your hand to Mr. Brees and say, I don't know how to do this. Yesterday, you guys worked almost in complete silence, and I would say 95% of you got most of your homework done in class, right?
Yep.
That's what I need. You cannot disrupt yourself. You cannot disrupt anybody else around you. On the back counter is one of those gridded papers if you want a table or a spot to show any work. You do not have to turn it in to me. Get your laptops out. Go ahead and get started. 100% by 8 a.m. tomorrow.